start here. Fourteen. Okay, can you see my screen now?
Yes.
Okay, thank you, Nick Aiman. Okay, by the way, I forgot who is the class representative? Sudah lupa dah itu. Who do you choose to be the class rep?
Akmal Irfan.
Akmal Irfan. Okay, okay. Akmal Irfan. Yeah. Ada dua Akmal. Just right here. Okay, how many? 18, eh? So actually we have another 3 students to turn it. Probably they are on the way. Tidur lagi ke apa? All right, shall we start? Now it's already about 8:34. Give another minute. We started 8:35. Okay, Azari, Azmi. If you found that your friend is waiting outside, okay, 20 students. We have another one to turn in. Okay, I think we better start now. All right. Assalamualaikum warahmatullahi wabarakatuh. I hope everybody is very, very well, fine today. You have a good weekend. Probably some of you balik kampung. It's a long weekend, isn't it? If you don't have a class on Monday, then you have a very long weekend. Okay. All right. So for a start, I'm going to go through the Google Drive. So this is, I've shared with you actually this morning, just now, a new slide, which is from the introduction here. All right. So introduction PDF. So this will be our main slide for today. And again, I'm going to remind you that the face-to-face Google Meet will last only maximum 30 minutes, and the rest I'm going to do a video. Okay, and you have to complete within 2 days, which means if you have class today, I'm going to post probably later in the evening, and then you have to complete watching the video until tomorrow night. Tomorrow midnight, 12 o'clock. So you have to complete by tomorrow 12 o'clock. Then you'll be considered to attend my today's class. Okay, can you get that? Right? So I've already shared with you ebook fundamentals, Sharkawi, our main book. This is very good book actually for moto, for drive, as well as for the power electronics. I just discovered that Sharkawi also discuss on the power electronic converter, the working principles, the equations. Very good in this book. Yeah? And I'm going to share another book with you. So add new file, upload, and references. There's another ebook, electric motor drive, which I found very good for you to refer to. So we have another book. Right, there you are. So in that chat folder, you're going to see these two books. Okay, before we proceed, can you, I give you 1 or 2 minutes, can you go and try to find this chat folder with you? You need to log into your account, Google Drive account, and then look for shared drive, shared with me. Wait, shared drive or shared with me. Okay, you need to go to shared with me. And please respond. If you have a problem, please respond to me. And then look for, wait,
Sir, link Google Drive. Letak mana, sir?
okay, your Google Drive. Have you used the Google Drive before?
Yes,
No.
but
Yes,
Yes.
I have used it.
Okay, so
linknya.
some of you may have. If you never use the Google Drive, you can go through the Classwork. Wait, I want to show this. Okay, let's say this is my dummy account, another account. So go to your Google Drive, Google Classroom. Where is the Classroom? Give me a second. Okay, so when you get into your Google Classroom, you will see this group, isn't it? So you go into that particular group, electric drives. Are you following me? Yes. Okay. Then go to Classwork. Okay. Go to Classwork, and then you'll find here class drive folder. Okay. Click that class drive folder. Then you will not be able to see anything here. This is not the one that I've shared with you, but you have to click this shared with me. Okay. Go to shared with me. Then you'll be able to see this electric drive folder here. Okay. Any problem?
No, sir.
Okay, great. So double click that. Then you see the one that I've shared with you. Go to materials. Then you'll be able to see all 5 PDF files that I've shared with you, or the course outline. You have 2 ebook, and then this is the slides I'm going to use today. Okay, introduction, PDF. Okay, right. Just let me know if you have any problems. Okay, if not, I'm going to proceed with the presentation. Okay, so that's introduction. class. All right, and the other one is I did mention about watching the video, isn't it? Okay, so of course there are many ways to share the video with you. I can just post, or I can just use a Telegram, isn't it? Telegram has a larger capacity of video share, so I can use that, or I can use Facebook to share the video, isn't it? I can use YouTube to share the video, but through by using this platform, I couldn't trace how long did you engage with the video. I mean, how long did you watch the video? Do you really watch the whole complete video, or you just 10% of your video, 20%? I couldn't get any feedback on that. So I'm going to use Add Puzzle. All right, I did mention last week, I'm going to use Add Puzzles, right? So from this Add Puzzle, I can easily trace how many percent that you watch the video. And you must watch the whole video to be considered to fully watch, or to be 100% attendance. Kalau tidak, you will not be considered to attend the class. So you have to watch the whole video. You cannot skip. If you skip, then the Add Puzzle will intelligently identify that you only watch, you skip that particular second. You will, they will be able to trace that. If you miss 2 or 5, how many seconds? 2 to 3, 5 seconds, then you will not be getting 100% watch the video. Okay, so I test the Add Puzzle with you. If you go back to your classwork, or if you go back to your electric drive, the platform, wait, Add Puzzle, electric drive, class members, here, assignment, in progress. Okay, I've shared with you this video. This is just for testing, just to know, just to give a test on you on electric drive. So when I go back to my electric drive, kenapa tak ada ni? Announce something to your class. Assalamualaikum. Oh, okay. Mistake. I must go back to Add Puzzle. Go to that thing. Post on Google Classroom. So I need to hit this button. Post on Google Classroom. Okay. Now, can you go back to your Google Classroom? Drive. Where is okay. Can you see this? Professor Madhya, my name, and posted a new assignment. So it become a new assignment. Yeah, it becomes a new assignment. So if you click that button, then you'll be directed to the Add Puzzle. Okay, so here you must have your own account. You must have account in Add Puzzle. So register the account under student's account and use the same email address with your Google Classroom. Clear? Okay, you did it later. I'm just going to show you what happens. So you'll be having that link to your Add Puzzle. So you click that button, then it will go to directly to the video. this video actually from the YouTube. Okay, so I can use the YouTube, but watch it through the Edpuzzle platform. Right? So if you you must view the video, watch the video through Edpuzzle, then you'll be considered. Then I can trace how many percent that you watch the video. So for example, this is 2-minute video, right? I play it, so it's a YouTube video. Talk about the linear motions. We have a rotational motor as well as the linear motor. So you can watch this video. It's very good. This is a traditional motor whereby the rotor will rotate with respect to one axis here. I mean one axial. Yeah. So it will rotate. I'm going to skip. Okay. Let's see what happens if I skip the video. So I'm going to skip it. Go to that point. Skip the video. And there will be one question asked. Okay. So I can ask you any question within the video. Enjoy the video? Yes. Can submit. Okay. Submit the button. Use the submit button. Click it. And then continue. So I will put some quick questions just to get you engaged with the video. Then I'm going to watch it, skip again, skip again, skip again, skip again, until throughout the end. And then there will be another question posed to you. Do you understand? Just click yes, then submit. Okay, so I've got 100 out of 100 because I answered 2 questions and I've got, don't worry about the question because just it will not be evaluated. Just to get engaged, to get you engaged with the video. All right, so to continue and then complete the video. So I watch the video and skip it, okay? But I will be able, through my through my Edpuzzle account, I can trace actually the actual time. Okay. So this is my account, Edpuzzle account. If I go down, look at that. Okay, Sroji Nawawi, I've already watched 50% of the video. Azmi, you watched the whole video? On time. Azmi.
No,
Sorry?
Yeah, I watched the full video.
You watched the full video. Did you skip? Did you skip?
No.
You did not skip. All right.
Since the other side, the video will not continue. It will pause.
Okay. Oh, you use your tab, another tab.
Yeah, I just want to try.
Okay, great. All right, okay. So, which means I can trace whoever have watched it or did not watch it. Then I can easily trace you. So that's why I'm going to use that puzzle as well as Google Classroom so that I can really get the feedback. I mean, get the identify who is not watching the video, does not watch the video, who the video 50% who watch it, right? So this is the 2 platform that I'm going to use, Google Classroom as well as Edpuzzle. Okay, so clear, right? Any questions? No, I consider that as a no. So let's start the the first slide, introduction, finish up. Okay, so this is the slide. short presentation slide video. Okay, can you see the slide now? Yes. Okay, great. EPO 640 electric drive introduction. My name's, and now we are in School of Electrical Engineering, College of Engineering, right? And we are actually still under center of our. Is it center? Ke apa dah? Saya pun dah lost with the. So this is my information on my room there. So probably we're not going to have a physical class yet. You also are not welcome. You are not welcome yet to attend the class, a physical class. So we're going to continue with the online class. This is my name. This is my room. And for queries, the best to contact me through WhatsApp. I've created a group, so don't worry. You can use the WhatsApp to contact me. Or if there is a case of just like we have WhatsApp going down last week, is it last week or last 2 weeks? The whole WhatsApp is down. Then I'm going to create a BIP group. BIP, the apps from the Turkey. It's a Turkey government owned apps. So I'm going to use BIP. BIP. Oh, why I can't write. Okay, I'm going to use a BIP as an alternative to the WhatsApp. Okay, all right. And this is EPO 640, 3 credits, semester 6 lecturers. I think I've explained to you last week. We have 3 lecturers. We are preparing the final exam actually, and we're going to submit the end of this week, inshallah. By the end of the course, I think there are 3 course outcome. This is course outcome. Identify the operation of various electrical electronic drive system, appraise various converter circuit topologies and control strategies in AC and drive system, and finally simulation. Perform problem solving related to application of AC and drive system using computer simulation tools. This is a 4 topics: electric drive, concept, methods, and design tools. We're going to discuss on direct current electric drive first, and then go to the alternate current, which is the induction machine electric drive, and other special electric drive, and of course the assessment. This will be the schedule. I missed this SC schedule for each week, right? So we're supposed to complete the introduction part last week, but of course, the first week being you still, get the Sims problem. Some of you want to switch the class, right? So inshallah by today, by Friday, we're going to complete the introduction and we start on the concept method design. Okay, so today I'm going to continue with the introduction, some introduction of the electric drive. And then the second week, we're going to have concept method design, the first topic on the concept method design tools. There will be 3 classes for concept method design. And then inshallah we're going to have a quiz, not that, probably 1 quiz for each topic, inshallah. And then DC drive will take 1, 2, 3, 4, 5, 6. 6 classes. We'll be focusing on the DC drive before we have tests on the 19th of November. And then we're going to have a semester break after that, isn't it? There will be semester break, if I'm not mistaken, on the 24th of November, or 22nd of November. Going to have a semester break, 1 week. And then next we're going to continue with the AC drive. Again, we have 2, 4, 6 week for the, 6 classes for AC drive. And then going to have other special drive, which is the permanent magnet, brushless magnet, brushless DC, motor, and then we have a semester break for the Christmas, end of the year, semester break, and then we come back and continue with the rest of the topic on the other drive of special drive, 5th January, and our final preparation will be the revision week. No, sorry, final preparation. We also have this simulation. Probably that simulation will be left until the end of the semester, right? So that 2 weeks will be allocated for that simulation. That's two. And then this is the assessment. We're going to have test 1, test 2, quiz, coursework, lab simulation practical, of course. The coursework of 10% will be on the simulation, and exam will take about 60% at 3 hours. So assessment again, 3 hours covering electric drive topics. The exam will aim to cover all electric drive elements, electric drive, DC machine, as well as the other motor drive. This is a set final exam. This is final exam. Okay, 3 topics. And then for the simulation, practice on electric drive, 8 hours, 4 times 2 hours timetable slot to work on the simulation with academic and demonstrator support. There will be one session where a lecturer will share with you how to simulate the circuits and everything, inshallah. And we're going to arrange that. And then you have to submit a single report through Turn It In. I'm not sure whether it's a group work or individual group. Individual assessment, individual, we call it, coursework or simulation. I'm going to let you know later on. Assessment details, 2 hours covering topic according to chapter. Test 1 will cover the first 2 topic, and test 2 will cover the other 2 topics on AC and electric drive. Okay. Things you should know well. Of course, vector representations and calculus. This is very important when you deal with the motor, the XY axis, XYZ axis, isn't it? The vector representation as well as calculus. You have to be able to integrate, differentiate, and the rest, the sinusoidal, trigonometric calculation of the things. And then number 2 is magnetic fields. You have to know what is intensity, what is a magnetic field, and then what is the right hand rule, and then left hand rule, FBI, and then you have this corkscrew right hand rule to identify where is your flux going through. If you have a current flowing that direction, then you have the flux that rotates in that direction. When you have a current flowing that direction, and you have FBI, isn't it? F, the force, the magnetic density, magnetic field, and you have this current, FBI. So this is motoring, and then if you apply the same FBI, then it's for generator. It's opposite operation, isn't it? Left hand rule, right hand rule, and the rest. Okay, magnetic fields. And then steady state DC circuit analysis, DC power. You need to know what is a power, DC power, and the rest. Steady state DC circuit analysis, and also as well as the power electronic operations of the rectifier, inverter, this AC controller, inverter, DC converter. So you must go back to your power electronic and start to do some revision, right? And then steady state AC circuit analysis, when you have RCL loads, you need to consider purely resistive load, capacitive loads, as well as the inductive loads. What happens to the power electronic circuits when you have these RCL loads? And then phase relationships, okay, V red, V yellow, V blue. What is the relationship between phase and line-to-line voltage? And power factor. What is a power factor? I think, I hope After you complete your powertronic, you'll be able to differentiate between the normal power factor when you have a sinusoidal signals. If you have a both current and voltage are sinusoidal signals, then the power factor is always cos theta, isn't it? The angle, the phase shift, the difference of angle between sinusoidal current and sinusoidal voltage. But however, if you apply the powertronics, the power factor is no longer cos theta. The power factor is actually the ratio of fundamental current to the RMS current multiplied by cos theta. And of course, in general, power factor equals to the real power divided by the apparent power. So these things you should know well, all right, before we go to electric drive. And then three-phase system, star and delta connection. What is the difference between star and delta connection? If you have a star connections, then the line-to-line voltage will be always √3, square root 3 of V phase, isn't it? But the current, the line current, equals to the phase current. And then then you need to look at the load, the R. What happens to star if you convert star to delta, isn't it? So this should be in your fingertips, right? Active and reactive power. What are those active and reactive power? What is the total power? Okay, 3 multiplied by V phase, I phase. That will be the total power or total real power. And then you have √3 multiplied by V line to line, I line, to get the active power. And then you have power transformers, the rest. Okay, so these things you should know well. Why study electric drive? Because we know that the most uncommon effective converter of electrical energy to mechanical energy and vice versa. So at the moment, this is the method to convert from electrical to mechanical energy using the motor as well as the electric drive. So the electric drive will control, the motor, the operation of the motor. So we need something to control the motor. Before this, when you learn about the electrical machines, you just focus on the machine itself, the motor itself, right? Which means the characteristic of the motor, DC motor, the characteristic of the induction machine, you only focus on that particular motor. But now you integrate the powertronic as well as the motor. Why? Because you want to control the speed of the motor as well. Or in terms of generator, you want to maintain the frequency of the motor, the generator, so that it can produce 50 hertz power to the grid. All right. So traditional application, of course, in industrial drive, you see a lot in the industry. You have a lot of motor, linear motor, rotational motor, pumps, isn't it? Generators. This is traditional application. It has been exist for a long time on how to use the pump, generator, so on and so forth. And then now we talk about expanding application area, where now we have this embedded generation whereby you integrate hybrid car, for example, electrical and hybrid vehicles. Yes, we see a lot of hybrid car now, especially from the BMW, and we have this electric car, all electric car from Tesla, isn't it? Okay. And if you know that the Tesla and all this hybrid car, electric car has a special tax discount. So, of course, there's still a problem with the electric and hybrid car, because if you want to replace the battery, it costs you a lot. Within 4 to 5 years, you have to replace the battery, and the battery will cost you about 100 over 1,000. So just like you buy a new car then, but still we talk about the green, more greener environment, of course you will be look into that. And of course you will not be reliable, dependent on the fuel anymore. So the petrol will not affect you if you have an all electric car. And then also we have an all electric ship, as well as, what time is it? 9, 7. Okay. We have another about what? Stop open 9, 4, 8. We have another 10 minutes, 10 minutes, inshallah. Okay, so we have expanding application area, embedded, all electric ship, more electric aircraft. All right, so actually I did my PhD on the more electric aircraft, whereby I designed that time I designed just the power supply for the trolley in the aircraft. So I need to consider the frequency of the aircraft is not the same as the one that we have in ground. Here we have 50 hertz, isn't it? In Malaysia we have 50 hertz. But if we talk about more electric aircraft, the aircraft have 400 hertz as a main frequency for AC. So why we need to have a high frequency? Because you want to reduce the size of the components, inductive component in the system. So that's why it works with 400 hertz, and the input is 150 volt. 150 volt, 400 hertz. That is the electric aircraft power supply. Okay, and then we talk about automation and manufacture. Why is this area becoming more important to the electrical engineer? Because of the growth of the powertronics. We have advancement in powertronics, microprocessor, because we have a new materials coming in, permanent magnets, and then the technological improvement are leading to higher speed machines. We know that now we have a bullet train, isn't it? Bullet train. All of them are actually use the electric drive. And there is a new technology which is a magnetic levitation, isn't it, for the train? So that's why there is no friction anymore. So the train and the rail is actually, there is a gap. There's no friction between the train as well as the rail wheel. So that's allow the train to move very, very fast, high speed. And we need to have a higher torque density and new machine topology, which only operate through powertronics, right? So we must use the powertronics, and that's why it's known as a drive. Higher operating temperature, high performance and energy efficient control, and the drivers. What drives the electric drive is energy efficiency and reduce CO2 emission. Why we need to move into this energy electric drive? Because of energy efficiency, and we want to reduce the CO2 emissions. We want to utilize utilize the energy. We don't want to have a waste of energy, and because of more electric transport as well as the renewable energy. Okay, so some basic questions on the fundamental. What constitutes an electrical machines? Number 2 is why are there different forms of electrical machines? Why we have so many forms of electrical machines? How do they work? This is what we're going to look into, the operating principle of the electrical machine. How big will a machine have to be able to deliver a particular power? So we need to look into the force, the total force, taking consideration of the friction, the load force as well. Then we'll be able to calculate the power that need, and that power actually will somehow relate to the torque, and torque also relates to the volume of the machines. So if you want to have a higher torque, the machine will, of course, will also proportional to the torque that you want to. Okay, what do I need to know to use a particular machine type? how can I analyze the method of working of a particular machine type? So what constitutes an electrical machine? So first is all machines are used to transfer energy between mechanical and electrical system. In terms of motoring, motor, it is a transfer of energy from electrical to mechanical, isn't it? If you talk about generator, then it is a transfer of energy between mechanical to electrical. All right. So electrical power is expressed as voltage times current. P equals to V multiplied by I, voltage multiplied by current. But mechanical power can be expressed either as, there are two forms. There is a two form of mechanical power, which is in the form of rotational power form. So the torque times angular velocity. So I put it as a PM, right? The mechanical power equals to torque multiplied by the angular velocity, the rotational speed. Omega m is the angular rotational speed. So subscript m refers to a mechanical quantity here. And then in terms of linear form, linear motor, it depends on the force times linear velocity. Sorry. So we have mechanical power equals to the force times linear velocity, V. V. So linear form, of course, the rotational form, your rotor will rotate in that direction. But if you talk about linear motor, then the motor will work in that linear form, in parallel with the road, for example. Okay, so there are two machines actually exist in this world, a rotational form and linear form. Okay, thus machines may be either translational or rotational, but they all involve mechanical movement at some time. Thus, all machines have two parts, one fixed stator and the other moving relative to it, which is known as a rotor, stator and rotor. So the conversion can be electrical to mechanical. So motor mechanical, I did mention that just now. Most machine can work in either mode. So most machine can work either mode. You can force it to become a motor, and at the other form, you can force that machine to become a generator. Okay, so why are there different forms? Okay, why are there different forms? Of course, the rotational ones all look very similar from outside. If you look from the outside, the rotational motor is similar. It's a round or rectangular body with a shaft sticking out the end. So kalau you nampak sini, you always see this particular isn't it? This is a motor. Differences may be due to the fact that the electrical power input is different. If you talk about DC motor, so the power that generate that motor, I mean the control that motor is come from DC battery, can be from car radiator. For example, the car radiator fan, it operates with a battery, and it may come from the DC supply. For example, the traction such as the underground DC supply is very large. DC supply for traction. This is for train and everything, and or via a powertronic controller, which means it is from AC, and then we have powertronic, and then DC, and then that DC will control the DC motor. Okay. Next, we can have a AC motor, which can operate from AC main supply as well as from the powertronic. So if you talk about powertronic, it may come from a battery, and then you have a powertronic inverter. So DC will be converted into AC, and that AC will control your motor. Right? The operating conditions are different. AC induction and synchronous, or AC synchronous. And then we have induction motor are able to produce a torque at any speed other than synchronous, while synchronous one produce a torque at synchronous speed, right? So we always have that for induction motor, there is the rotor will rotate slightly lower than the synchronous speed. Synchronous speed is the speed of the rotating magnetic field. You have to understand that. And ns, the synchronous speed, is always defined by 120 multiplied by the frequency divided by the number of poles. Is it 120F divided by P, number of poles. Okay. Why are there different forms, different operating requirements? DC machines were favored until some time ago for speed control. You can read that. Much of the theory for controlling of the machine type is based on manipulating the power electronics machine so that it looks to the control behave like a DC machine. Currently, the market for DC machine is constant or reducing. Disadvantage of maintenance problem of brushes. Okay, so the problem with the DC machines because it has some brushes to connect between rotor and the stator. There is a brushes, isn't it? So that's why if you can think of your, if you have a car, if your parents have a car, we talk about the motor to your auto, we call it tingkap tu your auto, bagi apa? Tingkap mirror. Dia punya kereta punya tingkap lah, motor. If you happens to have a problem with the motor, if you go to the repair shop, the workshop, the workshop, the man there will sometimes hit that particular motor, isn't it? It will bang into that particular motor because of the brush. Because of that brush is no longer clean. There is no contact between the stator and the rotor there. So there's a problem with the brushes. It will wear down brushes. The brushes will wear down. So there's no connection between the rotor and the stator. So you cannot start the motor. And so if you hit that particular motor, then there will be the rust. The rust get off, and then the motor will work again. So that is a problem with the DC machines. It will not work for a longer time, and that's why we have the special drive which is known as a brushless DC motor nowadays. Okay, and next is DSP and sophisticated control. DSP, digital signal processing, and sophisticated control. Variable frequency supply is now common, mostly for induction motors, but also for permanent magnet. Synchronous machine. Advantage. What is it? Okay, I'm about to finish my presentation. Okay, advantage is highly reliability and totally enclosed, fan, cool, and the rest. Okay, so last but not least, what are the different forms? Continue. Some machines cannot operate at all without a special power controller, because this machine really is highly dependent on the power electronics. So you must have this power electronic controller before you can use. For example, the switch reluctant motors. You have to switch the signals to your stator. You have a lot of stator there, so you have to switch in between that pole so that you can move we call it the rotating magnetic field as well as a brushless DC. So you must have this power train, and finally different motors have different characteristics, temperature, cost. So that's why they are different forms. Okay, so the rest of the slide I will continue into my video. I will record a video on that until the last slides, and I'm going to post to you later this evening, probably before 6 o'clock. I will post to you, and check your Google Classroom. Don't worry, just check your Google Classroom, and from that Google Classroom, it will direct you to the Add Puzzle, and from that Add Puzzle, you watch the video. So do not skip. If you skip, then you will not be considered to attend the class. You must complete the whole video. Okay, so any questions?
No, sir.
Great. Let's see how many of you. Just stop presenting. Okay, we have 20 of you. So ada seorang. Oh, Amir, just join. Kenapa tadi join tak, Amir? Is it because you wait for me to? Tak apa, tak kisah. Nanti don't worry. I'm going to share with this the video as well. I'm going to record. Of course, I recorded this class. So again, I'm going to share with you this face-to-face video as well. And as you need also to watch the video later on. Okay. So any question?
No, sir.
No, sir. Akmal Irfan, anything from the faculty? You want to share anything? Class rep, Akmal?
Not really.
Nothing, eh? Okay, great. Okay, so that's I'm only have a half an hour for face to face with you. I'm not going to go longer than that. Okay, so all the best. Enjoy the rest of the week. And wait for my announcement in the Google Classroom as well as the WhatsApp. Okay. All right, everybody.
The attendance, right?
I'm going to base on the video. You have to watch the video. Okay, I'm going to post it this evening. So you must watch a video so that if you watch the video 100%, then I will consider you to attend the class.
Okay, sir.
Okay. All right.
Sir. Thank
Bye.
you, sir.
Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof.
Thank
Thank you.
you, Prof.
Bye.
Assalamualaikum.
Waalaikumsalam.